Okay, we're going to backtrack a little bit. Earlier in the year we learned, we talked about circumference in chapter 11, but we skipped part of that lesson because we didn't have prior knowledge on circles. So we're going back to it because you will see questions like this on tax and star. Okay, so circumference and arc lengths. The definition of an arc length, definition here in this first box. Okay, an arc length is a portion of the circumference and it is measured in units. It is measured in units, comma, not degrees. Oops, there we go, not degrees. Okay, well, I'm sorry, we forgot to put arc length in the middle of this box. This is going to be examples of finding arc length. Now, we had found arc measures. This is actually arc length, which is a portion of the circumference. And if you notice, circumference is never found in degrees. It's only found in units, inches, feet, meters, centimeters. Okay, so the formula to find arc length, and I am just not spelling very well today, is arc length is to circumference. Now what I'm going to put down here, instead of writing out the word circumference, notice I'm putting the formula there. Okay? It's a portion of the circumference of the circle as the measure of the arc, as the, let me write out the word measure. Measure of the arc is to 360 degrees. Okay, this formula is your circumference. Let's go ahead and write that down. And the measure of the arc, that is always in degrees, because that's what we've been doing. This is what you've been used to. That is a portion of 360 degrees, just like the length of an arc is to the circumference. So what I want to do is I want to practice a problem finding an arc length. So I'm going to draw a circle. Well, let's go ahead and put practice right here. We're going to draw a circle, and we're going to give it a radius of, let's say, 8. All right, and we're going to give an angle measure, a central angle measure, let's say, of 94 degrees. That's just a little bit more than a right angle. Okay, so now then, if I want to find the length of arc, I'll put it right here, AB, find the I'm sorry, not the measure, we want the length. Find AB. Okay, I want to know how long this is. Well, we know its measure is 94, but I want to know if this is 8 inches, how many inches is this arc? That's what we're looking for, its actual length. So we're going to write the ratio using this formula here. The actual arc length, we don't know, is x. And the circumference of this circle is 2 pi 8, because our radius here is 8. The measure of the arc is the same as its central angle, so its measure is 94 out of 360 degrees possible. All right, now this is just a matter of cross products. Anytime you have proportionate ratios, it's just cross products. So we've got 360x is equal to 2 pi 8 times 94. So in our calculator, I'm going to type in 2 pi 8 times 94, and I get a rather large number, 4,724, and I don't think you can see that very well in that recording. 4,724 point, I'm going to go 955. All right, and the last step is to divide by 360. And when we divide by 360, we get about 13.125. I rounded to 3 decimal places. So that portion, this arc length portion, is just over 13 inches long. Okay, so now we've gone from finding its measure, its how many degrees it is out of 360, but how long that is in proportion to the entire circumference of the circle. All right, so now this is important to remember. Remember that the measure of an arc is in degrees, but the length of an arc is in units. And by units, I mean centimeters, meters, feet, inches, anything like that. Okay, it's very important that you don't get those two items confused. When using this formula here, you can, if you actually knew the arc length, you would put it here, and then in this place you might be solving to find the length of the radius of the circle. So this would be 2 pi r, and you would do cross products, and then you'd be solving for the r instead of the arc length. So that is something that you might come across in having to do. Okay, then the second part of the notes is 11.5, which is the area of a sector. Okay, now a sector is a pie-shaped piece of a circle. If you were to cut a circle into, let me show you a picture here. If you were to cut a circle, a pizza, into different pieces, this would be considered a sector. Sectors are on your CDs. If you ever, if you have a CD, and the way it records, a computer divides it into tracks and then sectors, and then saves information within here. Anyway, so we're going to be finding what these pie-shaped pieces are as far as area goes. So looking here, this is going to be in the center, area of sectors. All right, and its definition. Okay, would be a pie-shaped area of a circle. A pie-shaped area of a circle. Draw a picture of that. Central angle here, this would be your center, and this would be considered a sector right here. This is also considered a sector, this majority out here. You could also find that as because it doesn't have to be the smallest one. In this case, it's just the shaded part. Okay. All right, now then, the formula for finding the area of a sector is just like that of the arc length, okay? But instead of putting arc length, we're going to put area of sector. And the area of a sector is a portion of the area of a circle. And to find the area of a circle, it's pi r squared. And that is equal to the arc measure divided by 360. So again, a proportionate ratio. but this has to do with area, so it's the pie-shaped section is to the entire area of the circle as the measure of the arc is to the measure of the entire circle. So let's put an arrow right here and write area of circle. And arc measure, again, is always in degrees. Okay? All right, now then, to do a practice problem, we're going to draw a circle. And we need to give, we can do kind of the same thing we did earlier. We have a radius of 8 inches and a central angle of 94 degrees. That's kind of sloppy. That didn't really come out to be the center. I don't like it. I'm going to have to fix that. There we go. That looks a little better. Okay, so 8 inches is the diameter, the radius, and 94 degrees is the degree of the central angle. All right, so we're going to use this setup right here. We don't know and we're going to find, here we go, A, B, and we'll call this C here. So we're going to find the area of the sector formed by angle ACB. Find area of sector formed by angle ACB. All right, so the area of the sector is X. We don't know that. The formula for the area of a circle is pi r squared. So for r, we're going to use 8. So that's pi 8 squared. And the measure of this arc is 94 degrees. And that's over 360 degrees. So just like we did arc length, we're going to do cross products. So we have 360x is equal to, and we're going to take pi times 64 times 94, which gives us 18,899.8214. Okay, I didn't round that. That's actually where it stopped. Now, to divide by 360, x is going to be 52 point, and I'm going to round this to 1 decimal place since I'm running out of room, 52.5 inches squared. And we have to put squared because we're finding area. So this shaded region right here has an area of 52.5 square inches. All right, now then, remember area of a sector is a portion of the area of the whole circle. An area of a sector is a portion of the area of a whole circle. And write your dimensions. Write your dimensions. Oops, misspelling dimensions in square units. Okay. And again, just like that with arc length, you might be giving the area of the sector, and they want you to find the length of the radius. And in that case, this would be your unknown number right here, and you would solve this whole thing for the radius. That would be your unknown. In this situation, our unknown is our sector area. We could also have the sector area and the radius, but yet we don't know the arc measure, and that would be our x. So this is just a proportionate ratio. You need 3 out of these 4 components, and then you can solve for the 4th one. Okay, thanks guys.